and welcome to Active Archiving with Amazon S3 and turn to Glacier. So today we're going to review, first of all, what is Active Archiving, talk a little bit about Amazon S3, our massively scalable object storage, and then talk about how you can take advantage of cost efficiencies and improve your overall TCO by tiering through the multiple tiers available within Amazon S3. Including Glacier. So with that, let's get started. So at a real high level, what we like to talk about and what we see is in the industry, and many of you probably who have joined today see as well, is the fact that data has gravity. In fact, data is getting larger and larger and larger, right? So if you're in the media industry, you're seeing video going from standard def to high def, but now 4K and even 8K video, genomic sequencing, obviously for any particular genome. It takes anywhere from 300 to 500 gigabytes per genome to sequence. So if there's thousands or millions of genomes, that adds up to many, many exabytes very quickly. Seismic data, financial log file analysis, and IoT, when there are billions of objects writing to data, writing a stream simultaneously, that can also lead to many petabytes being driven simultaneously. So again, and what happens is, once you aggregate this data, once you have this much data, it becomes more difficult to move around. So what we say is data has gravity, and at a very high level it means perhaps when data was more textual or smaller, you could move that data around and facilitate processing, sending it from point A to point B to point C. And we'll get into an example later on in the webinar of Sony and their workflow processing. And that's what they used to do, is where you move it from point A to point B to point C. And that's a common workflow for media and a common workflow for many industries. However, as the data size increases, it becomes increasingly difficult to do that. So a lot of storage infrastructure and processes closer to that data. So rather than moving the data around to the processing essentially takes advantage of this large centralized data pool. Variously called data lake, media lake, or other term, but essentially a large pool of aggregated data in which you can now use elastic computing and elastic services on demand. So I want to just give everybody a little bit of a refresher first on AWS and our storage portfolio. So Amazon Web Services has a range of storage offerings that I like to talk about as four legs of the stool. So for those of you that are familiar with traditional enterprise storage, we have the equivalent of Block and SAN. So we offer Amazon EBS, Elastic Block Store, and then our local instance stores as well for the block for the local storage. Secondly, we offer Amazon EFS, Elastic File, and that is our managed NAS offering, especially for workloads that require dozens or hundreds or even thousands of locations or thousands of EC2 instances to access that data simultaneously. So then finally, when you think about kind of the scalable, really talking about millions or billions of objects, you can see we have Amazon S3 and then Amazon Glacier. And that's where we're going to primarily focus on today on the session. And that's our massively scalable object store. So those are three legs of the stool. But as importantly, one of the big things that we talked about in the first slide was that data has gravity and data is large. So we have many opportunities and many options to move data into Amazon Storage Portfolio. And we'll hit on some of these today, but essentially that's what we consider the fourth leg of the stool, are these data migration options. So we'll hit on Snowstar, we call it, but we have Snowball, we have Snowmobile, we have Snowball Edge that we introduced last year at reInvent, and a number of different solutions in the Snow family to get data in and more of a batch migration into these large object stores. We have Storage Gateway, we have Direct Connect, we also have a range of third-party connectors and options that allow you to get data in. And we'll review each of these at a high level when we talk about getting data into these large archives in the first place. So first I want to start off of what is an active archive, and depending on who you ask, you might get a little bit of a different definition. But the way that we think about an active archive is if you think about backup is hopefully you'll never have to retrieve it. So you back up your data, you put it on tape, and then perhaps have it off-site. And in the case of either malicious or accidental deletion, then you can recover those files. An active archive, to contrast that, is data, in fact, sometimes large data sets that's more actively used, but still is static, unchanging. And so I'm going to review a couple customer examples here. But again, if you think about broadly speaking, it's larger data sets like media, audio files, images that are static, so they're not changing, but that need to be accessed and like to be accessed on a more regular basis. So therefore, the definition of active archive. So SoundCloud is a great example using an active archive. They're a customer of ours, and what they do is take, if you've gone to the site, and I encourage you to, take audio files in from musicians and producers from around the world. The audio files are then transcoded, and they're stored in multiple formats, and they store petabytes of data. What happens, though, under the covers is they're storing that primary data, what you see when you go to the SoundCloud site, on S3, but then they store a second copy on Glacier, and that's the the high resolution, if you will, or the higher bitrate masters that they store for that active archive on Glacier. And then, should they want to transcode it or you want to get a high resolution copy, it can be retrieved from Glacier. Again, so that's one use case of active archive. The second is DigitalGlobe. So DigitalGlobe, you might be familiar with. They have many satellites that constantly are taking lots of images of the Earth around the world. And DigitalGlobe, before their transition to AWS, stored all of that in a combination of on-premise disk and tape libraries. So they have an over 100 petabyte image library consisting of 6 billion square kilometers and basically generate new images every year via their network of satellites. And they've just launched some more satellites that will even take increasingly high resolution images, and so those will obviously even increase likely that petabyte rate. Here, what they've done is they've transitioned to AWS, and they're again using a combination of S3 and Glacier to be able to serve up those images where before they were located or stored on tape, so it was a lot more difficult to retrieve and access those images. Third example is healthcare. And healthcare is interesting because it's more of a regulated industry, and so there are compliance and retention requirements. So Philips, who we're partnering with, has their Health Suite digital platform, which is powered by AWS. They have over 15 petabytes of patient data, and that continues to grow. And they archive that data for decades. So there are very specific healthcare laws, and those of you that are on the phone are from healthcare or other regulated industries, there will be different laws and different regulatory bodies that will regulate your industry. But for example, for healthcare, depending on age of patient, the retention requirements are either 7 or 21 years, again, depending on age of patient for images. And so again, that data not only has to remain archived, it has to remain unchanged and proven to be locked down and retained for that period of time. We'll talk about some very specific capabilities that we have within our Glacier service called Vault Lock that allow for that retention period to be maintained. So kind of to summarize what Active Archive is, there's a range. So Active Archive is more actively used data that is static and is retained for a period of time. So you can think about media, healthcare, financial services, oil and gas, digital preservation, or any kind of long-term backup. And increasingly, especially for those customers on the phone and in the webinar, with more consumer-facing sites, log files are also increasingly active archives that are used and stored, perhaps analyzed short-term and then over time reanalyzed as different processing methods are made available. So archive, data retained for the long term for compliance or potential future reference. So that's the definition. So let me just do a little recap of our AWS storage offerings that support this active archive solution. So first of all, we have AWS, our Amazon S3 simple storage service. This service has been around now. We just celebrated our 11th birthday. And this is a lot of what I think customers think about when they think about Amazon scalable storage offerings as S3. So that is for active data or hot data. And again, at any point in time right now, we have millions of transactions occurring simultaneously around the world in all of our regions, and again, really allowing for that scale and global distribution and global access anywhere by anyone. So we also have a second tier of slightly cooler data. So we call that S3 standard infrequent access. And that's for less frequently accessed data. Very similar characteristics to S3 in terms of that large object store, massive scalability, and millisecond access. But we provide that at a lower cost to S3 standard. And so why wouldn't you use S3 infrequent access for everything? Well, certainly for what we're going to talk about today for active archives, I would say that you're probably going to be using S3 infrequent access primarily for that use case, even for the more, let's call it hot data, and standard probably for a very small amount again. And the difference between S3 standard and S3 infrequent access is price, first of all. So S3 standard infrequent access, again, in the US, it's a penny and a quarter per gig versus 2.1 to 2.3 cents for S3 standard, depending on how much data you're storing. But it's less expensive, but there's also a penny per gig retrieval fee. So again, if you're not retrieving data often, then you would definitely want to put it into S3 infrequent access. And finally, Amazon Glacier is really for true archive, and especially for the conversation we'll have today around active archive. Amazon Glacier is a great solution starting at 0.4 of a cent in, again, major public regions. Depending on the region that you're in, that might change slightly, but in major public regions in the US and Europe, it's 0.4 of a cent. And that's for that cold to slightly warm data. The difference between S3 and S3 infrequent access and Glacier is that the first two are millisecond access. So, and then Amazon Glacier can start with the expedited tiers and expedited retrieval at around 1 to 5 minutes. So again, it's minutes versus milliseconds. And so that's really the big difference. And obviously, as you go down, there's going to be a lower cost associated with that. So we stitch all of this together for our customers via something that we call lifecycle management. So, and we'll get into a little bit more detail on this, but again, if you think about your average archive or your photo libraries or videos or anything, for a very short period of time, that data will be very, very hot. So I think you saw in the waiting room, you had Huddle. They're a good example. They have coaching videos, and those videos are reviewed by coaches after the games, probably for maybe 10, 20 days. But then very quickly thereafter, say, for 20 to 30 days, they're going to get a little bit colder, and then eventually, they might just be accessed on a very irregular basis. So what the data lifecycle management is a capability within our storage that allows you to set dates to transition. So say keep it at S3 standard for 10 days, move it from 10 to 30 days to S3 infrequent access, and then finally move it off to Glacier, or in some cases you might want to purge it entirely. So we introduced a whole host of new capabilities also to support our customers who have the use case for active archive. So one of the things that we heard from customers was, this is great, you have 3 tiers of storage. You have Amazon S3, you have S3 infrequent access, you have Glacier. But I want more visibility. I want more insight into my data. So just recently at our reInvent conference in December, we announced a whole host of analytic capabilities that allow customers more insight into their data. So we talked a little bit about lifecycle policies for disaster recovery purposes, or for simply having data locality. We have already a capability called cross-region replication, and then we already had event notifications to say, for example, you're writing data in and you want to trigger an event like a thumbnail creation. All those capabilities already existed in S3. But as you can see, we introduced a whole new set of capabilities to allow customers to more effectively manage and classify their data. I'm not going to go through each one, but I'm going to highlight a few of them that are relevant to the active archive use case. In this case, data classification and management, as well as storage analytics. So with data-driven storage management for S3, this really answers the question, what should my lifecycle policy be? So prior to the introduction of this, customers, say, for example, would take a look at their log files and say, okay, great, my data was hot for 10 days or 5 days or 30 days. But in order to get insight, they'd have to run it through an EMR job or guess. And so what we did is we introduced, based on customer feedback, storage analytics that allow you to take a look at essentially the heat map of data over time. So what you see on the screen here is really a time series of the data accessed on S3. So on the top chart you see basically the blue and purple combined is the total amount of data stored. Along the bottom you see the date, so over time. And the purple is what is the percentage of data that's accessed. So you can see on the 12th of October, there's a little bit more, and then we had some peaks near the end of the month, but in the 13th through 16th, there was very little access. On the bottom, you can see that what that translates into in terms of percentage retrieval. So even though it looks like a lot, you can see that it's anywhere from 0 to peaking out maybe at a little bit under 1% at the end of the month at its most hot. So what this allows us to do then with data analytics is, A, you can export this. So you can take a look at this in your favorite analysis tool or export it, say, into our QuickSight offering. Or you can now export it, and if you run it for about 30 days, what we'll come up with is a recommendation. So we have essentially recommendations come out of this data analysis that recommend a lifecycle policy for you. So for example, given the previous data analysis, you can see that the, basically how much was accessed over which period of time, over 30 days, over 30 to 45 days, over 45 to 60 days, et cetera, all the way through. And so you can see where it's green and yellow. And so essentially what this does is provide you a mechanism, an intelligence to make a recommendation for your lifecycle policy. In this case, a whole host of data was accessed less than 30 days, but then it dramatically drops off after 30 days. So somewhere around 30 days, you would set a tiering policy to tier from, say, S3 standard to S3 infrequent access to optimize. So that's essentially, again, we don't do that for you intentionally. We want to provide you the analytics and then have you make the decision based on those analytics. And so again, you can use this tool, but you can also take the output of those analytics and perform your own analysis. So the other thing, especially for active archives, we introduced is an exciting new capability called tagging, so object-level tagging. And so what this allows you to do is classify your data. And a lot of people say, well, why is that interesting? Well, think about if you're in a compliant industry and you have active archives that have patient data. And so some of that patient data is very restricted in terms of the security policies and access requirements that you want to be able to provide to only a very, very few select folks. So you have certain security requirements and you have actually certain retention requirements. Per my discussion earlier on healthcare images having to be around for 7 or 21 years, if it's image data, then you may want to tag that as an image data, and you may want to actually additionally tag it with a type of retention policy, say 7 or 21 years. You can create a mutable tag, meaning an additional metadata element per object that applies additional information about that object. So in this case, you could say, I have a set of objects that need to be retained for 7 years. I have another set of objects that need to be retained for 21 years. And I have yet another set of objects that they're fine, and basically they can be accessed by everyone because it's not patient confidential information. And frankly, because it's just temporary data, after, say, 30 days, you could purge that data. So what you could do is now start to classify your data by different security requirements, by different data lifecycle policies and different retention policies, and then combine that with lifecycle management and AWS and S3 security policies to be able to have very granular definition of what data can be accessed by whom and which lifecycle policy you want to apply. For example, how long you want to retain it and at what point do you want to purge it. For financial services and insurance industries, for example, you may want to you need to say keep data around for X amount of years, but after that, you may want to have an automatic purge policy. So again, you can set up classification and categorization per object to be able to allow you to do that. So there's a lot of value and a lot of power in this capability for object level tagging. You can have up to 10 tags per object, which really allows you almost an unlimited set of capabilities to apply security and different policies to. It's a very powerful tool that's available on S3 for the organization and classification of your data. So we've talked about S3. We've talked about S3 and frequent access. So Amazon Glacier, which we're going to talk about a lot for the rest of this webinar, is our extremely low-cost active archive storage service. It starts at around, as I said, in major public regions at around 0.4 cents per gig per month. That is in the US and Europe. In other regions, it's slightly higher, again, depending on the region, but roughly in that range. We offer and we introduced some new retrieval options. So think about these as two, axes, if you will. You have a cost for storage, so you store it, and then depending on if you want to get it fast, medium, or slow, you can pay a different amount to retrieve it. So we offer 3 retrieval options, what we call expedited. That gives you the data back in 1 to 5 minutes. A standard tier, that's 3 to 5 hours, and then a batch mode of 5 to 12. And each one of them has a different cost, and we'll go through that in a little bit more detail in a little bit later in the webinar. All of our solutions, so S3, and Frequent Access, and Amazon Glacier offer 11 nines of durability. And I'll go through what does that really mean a little bit on durability. But it's essentially, if you think about in a site where you have one copy and then you have a second copy at a remote site and then you have multiple copies of tape, it offers essentially a higher level of durability than that many copies of tape. So we'll talk about that and go through an example for media archive in comparison to on-premise tape and then a second copy offsite and really what that durability means. Data is encrypted at rest and it offers a great deal of compliance and data management and cost management capabilities. So for Glacier, there's some basic concepts that are a little bit different than S3. So rather than buckets, that's the organizational concept in S3, we have something called vaults in Glacier, and that you can have up to 1,000 vaults per account. We offer archives, so that's the basic unit, if you will, that can go up to 40 terabytes maximum in Glacier. We have an index that we call an inventory, and then we can offer, obviously, a number of different ways to access Glacier that we'll go through. So those are the tiers, if you will, of storage and the capabilities that we have. So now let's talk and get back to, what do you want to do with your archive? And what are the elements when you think about archiving and then retrieving that data around cost and other considerations? So first, I want to think about what do people do today? What do customers do today? And I talk to many customers, and this is what we see. We see disk and then back-ended, perhaps and tiered off to tape. So that can either be robots or even off-site. So we often see then every 3 to 5 years, then a tape refresh cycle, off-site tape vaulting, and specialized software and personnel to access that data. So what we can do is eliminate the tape, eliminate the disk, and make it available essentially everywhere in the world and allowing for very, very distributed workflows. So these are areas that we're going to dive into and showcase with a couple customer examples. But again, really making this, and I'll go back to the DigitalGlobe example, they talked about really assets being held prisoner on their tapes. And why is that? Well, there's some friction that develops when you're, say, getting a request for data or an archive, and then you have to go offsite to get that data back. So there's friction in terms of time, there's friction in terms of cost of personnel, and there's friction in terms of, is that tape going to be readable, right? And so there are all kinds of friction points. When you move that into AWS, into the storage tiers that we just talked about, essentially unlock those assets and make them available, and then new and interesting, either for internal use, you get improved efficiencies, or for external use, new and interesting monetization schemes can emerge. So second aspect to think about is durability. So consideration, and again, I think I talked about this a little bit earlier, but if you think about your traditional media archive, say for the entertainment industry, there might be a single copy and on site, and then maybe 2 copies of tape. We did an analysis and worked with a third-party consulting firm, and essentially they came back and said, that's the equivalent of about 4 nines of durability. We then looked at and said, well, what if you have 2 sites, each with a copy of tape? And again, that's equivalent to about 5 nines of durability. So if you look at S3 or Glacier, any of the tiers of storage, what we offer is 11 nines of durability. And so under the covers, what we offer, and the reason that we can offer that level of durability, is that, number one, we store the data across a minimum of 3 different facilities or 3 different availability zones. So that's, say, for each with different power, different floodplains, and different connectivity. So if at any time the data say a site goes away for some reason, the data can always be accessible via the data in the remaining 2 sites or 2 availability zones. So that's kind of an availability aspect. If you look within there, we're actually constantly checking the data under the covers, doing fixity checks, and making sure that the data is not is what it is, especially for long-term retention and archives, that the data is not corrupted. And if you think about what happens in the real world, there are, and you start talking about storing trillions of objects, the likelihood is something's going to happen. There's a bit flip, other things happen deep in the bowels of the infrastructure. So what we're constantly doing is assuming that's going to happen and constantly taking corrective measure to make sure that the data that was stored is matched against the data that's there presently. And if there's anything as far as bit flips, et cetera, we correct that under the cover. So we're constantly checking and doing fixity checks. So that's an additional benefit versus, say, traditional systems where you'll have to manually do that, manually scour potentially millions of files or billions of files across tapes with, the likelihood that you might not be able to read some of that data. So that's a couple, and we will be happy to go into more detail around durability. But again, durability is a real tenet, especially when you think about storing really archives for 1, 2, 5, 10, 20 years, is that durability aspect of the archive. So we store it for the long term. We've built in fixity checking, as I said. And then if things are, say, there's a bit flip under the covers, and it's again, that's what happens in these large, trillions of objects of scale systems out there. We're constantly assuming that will happen, and we're taking corrective action all under the covers, and all of that is seamless and transparent to our customers. So that's the durability aspect. The next aspect of getting to your data is, do you really want to go offsite and get your data via tape archive and spend hours or days to retrieve it? So with Amazon S3, as I mentioned, that's millisecond access. But with Glacier, we offer a few different retrieval tiers. So we've offered and introduced in December at reInvent 2 new retrieval options. So our standard option, which is our option that was available until December of last year, allowed customers to retrieve that data in 3 to 5 hours. But what expedited retrieval did was open it up to new markets, in particular, especially for active archives, for media customers, or customers storing images. They might not be able to wait 3 to 5 hours for that retrieval, but they may only want to retrieve 1 or 2 images or videos or audio files in a much smaller period of time. So what we can do is offer with our expedited retrieval tier a 1 to 5 minute retrieval. So say you have videos, and the good example is a media archive. You may have a production that you're doing, and you may want to you may have weeks to say put to that production together. Well, for that, you may want to use our standard retrieval model to access those videos and get that at a very good cost of a penny per gig retrieval. However, in the case of, say, a news or sports event that's occurring, and there's an event or some activity that you want to pull a video for, we offer an expedited retrieval tier that allows that access to that video in 1 to 5 minutes. And again, so you can pull that out very, very quickly and compare that, say, to running to an off-site tape facility where it might take several hours. We can offer that a much, much faster SLA. On the flip side, say, again, using the video use case, if you want to go through the library and transcode that library, you can take your time to do that, but ideally you do that at a very cost-effective tier in a cost-effective way. So what we offer is a new bulk retrieval tier that addresses that use case. So this is for batch processing. So I've talked about video, but you can also think about if you have log file analysis or you have a large data lake of data. And again, you can run in the background, and you want to be able to use some of our elastic computer spot instances to be able to process that data. You can use our bulk retrieval to comb through that data at a very slow, leisurely pace and basically pull back petabytes at very low cost so that you can process that data. Again, so we offer a very unique range of capabilities with Glacier depending on your requirements for active archive. So that's access. Next thing I want to talk about is application and data management. So how do you get data into directly via the API, via S3 API, or there are a host of third-party options that are available for S3 as well. So one way that you can get into Glacier then from S3 is via the lifecycle integration that we talked about. A second is we actually offer a direct API and SDK for Glacier that we'll walk through in a minute. And thirdly, there are also third-party tools and gateways that you can access and use Glacier to tier 2 for your archive tier. And I'll walk through each one of these in turn. So first is the S3 Lifecycle. So I think I mentioned it at the beginning. Let me dive a little bit deeper now into S3 Lifecycle and how you can use that to tier into Glacier. So again, we have 3 tiers. We have for active data, S3 for infrequently accessed data, S3 infrequent access, and then finally for archive data, as I said, your Glacier tier. We have data lifecycle management that allows you to move data between tiers. Again, as I said, for example, your hot data might be hot for 10 days, and then you're able to move it, say, to S3 infrequent access, and then after 30 days, say, move it off to Glacier. One thing that we introduced, and I mentioned earlier now with where this all comes together, is this object tagging capability. So what we introduced was this capability now to say, great, what we want to do is for patient data that needs to be retained for a longer period of time, move this data to Glacier and keep it at the Glacier tier. Now for data that doesn't need to be, you can say another class or another tag that can be purged in a shorter period of time. You can set lifecycle management to say after 30 or 45 days, purge that data. So here's an example of a lifecycle rule. You can set this through the console, or you can also set scripts up to do this via the CLI. But here, as an example, we have first a standard infrequent access, so an object to move it to Glacier, to S3, infrequent access from S3 after 30 days, and then after about a year, then move that to Glacier storage class and keep it available then indefinitely. You could also see a third option that's not checked is if instead of archiving to Glacier, you simply wanted to expire or delete that object, you can do that as well. Again, we warn that would permanently delete that object. So, we want to make sure that people know what these different lifecycle rules can do in terms of purging and object deletion. So obviously we highlight that here on the screen. So that's the lifecycle management. That's a very common way to get data from S3 tiers into Glacier, especially for active archives. The second way to get in is directly via the Glacier API. So here, we won't go into all of the semantics, but there's a separate Glacier API. But essentially, you create a vault. You configure your access policies to that vault, and then you can simply upload the archives. And again, it's very similar in semantics to S3 access, but it does have a slightly different interface to allow you to access capabilities like retention and capabilities that are unique to Glacier, like larger archive sizes up to 40 terabytes. So how do you get data in now? So that's the programmatic interface. Oftentimes, as I said, data does have gravity, so it takes a while to move the data. And so we offer a number of different mechanisms to get data in, either AWS, but also third-party options. So certainly you can transfer data over the internet. We also offer something called AWS Direct Connect, and that's something especially for customers who are constantly accessing, say, in a hybrid environment between an on-premise, say, video editing and storing the data in the cloud. Then you might want to consider having an AWS Direct Connect, which is a high-performance, dedicated bandwidth between your site and AWS. And thirdly, we offer a solution called Snowball. You might have seen it or heard about it, but essentially this is your one-time batch move. So whether it's terabytes or petabytes, Snowball allows you to move essentially batches of data, especially when you're first transferring or migrating your archive. So we introduced a new version of Snowball, also called Snowball Edge, at reInvent in December. This is a Snowball, again, a petabyte-scale hybrid device that allows two functions. One is data shuttling, so you can it presents an interface, presents an S3 endpoint interface, it presents an NFS interface, it presents an HDFS interface, a number of different interfaces to get your data into the device. Then the device it's secure. You can use your own keys. It's encrypted, and load up the data, ship it off to AWS, and appears in your S3 bucket. So that's the data shuttle device. We also introduced the capability for onboard compute within our Snowball Edge device. And so you can think about, especially for customers that are, say, again, in media or remote data collection, say, ship or seismic collection. This is a great device to actually not only provide data shuttling, but also do some local processing on that data, so that in addition to having just the data shuttling capability, you're able to actually create, say, thumbnails or do some limited processing in the device itself prior to it being shipped back to AWS. So it's a really exciting, more edge computing device in addition to a data shuttle device that we introduced. So lots of different use cases for Snowball. So Scripps is a good example of an active archive for media. Philips, as I mentioned, also for healthcare. A company called Dev Factory, who's a customer of ours, works with a lot of their customers to consolidate and do large data migrations and to consolidate data centers. And so these are all very good use cases for Snowball. And if Snowball is not big enough, we also have Snowmobile, which allows you to move up to 100 petabytes in under a month. Again, we had a good case study with DigitalGlobe that talked about their migration with Snowmobile at reInvent. This is available for larger data sets. Usually, especially for active archives, if you have under a petabyte or two, Snowball's really sufficient, especially with 100 terabyte units. That's about 10 Snowballs. But when you start getting into double-digit petabytes, we have Snowmobile available as an option to do large batch migrations from an existing data center. And finally, we have an AWS solution called Storage Gateway. So Storage Gateway has the ability to provide an NFS interface, an iSCSI interface, or for tape solutions, a VTL interface on-premise. It's a virtual machine. And so this allows easy integration into existing enterprise workflows. The NFS interface in particular is super interesting in that if you write a file, say an MPEG file or a text file locally, that will appear in your Amazon S3 bucket in and then what you can do is say trigger different types of conversions or transcoding or other activities to occur when it's in that S3 bucket. So there's some interesting use cases, and our roadmap for Gateway also is pretty exciting in terms of allowing even broader use cases, particularly for multiple sites and multiple gateway uses. So stay tuned for that. When it comes to Glacier and integration for active archives, there's a couple different use cases for Gateway. Obviously, as I mentioned, you can write the data to an local NFS mount point, and then that data will appear in S3, and then you could tier that, say, to Glacier, or just keep it in S3 or S3 in frequent access. Or you can use the VTL mode, which looks like a local tape device. You can use your backup software, and then that'll write the data to Amazon S3 on the back end. We have something called virtual tape shelf as part of that VTL mode that then will tier that off to Glacier. And the analogy is if you have online and offline tapes on premise, the virtual tape shelf is, think about it as kind of an unlimited pool, if you will, of shelves for that more offline tape. What's happening under the covers is we are actually tiering that off to Glacier. So this is another example of using Glacier for tape and for archive using Gateway. So when do you use which solution? Well, use the lifecycle policies and to use it for Glacier if you want to be able to access via S3. It's very easy, and if you have applications that want to use S3 object keys for that capability. If you want to take advantage of some of the Glacier capabilities, or you're managing, say, an external metadata index anyway, then you can use the Amazon Glacier interface directly. And finally, if you want to simply just plug and play into your environment, you can use our gateway or any of the third-party tools and solutions that we talked about at the beginning in the first slide that provide support for Glacier. So those are the tools. Now we talked about what are the problems, what are the use cases, what are the tools. I'm going to dive into one particular use case and do a little bit deeper dive because this is a common use case. I think we talked about healthcare, we talked about financial services, but a very common use case is media and media archives. So traditionally what we see, and this is the interesting thing, is whether you're talking about media or whether you're talking about imagery, many of our customers have very similar workflows and similar infrastructure today. And what they have is typically an on-site archive consisting of a tiering of disk and tape. And then they have a second off-site tape archive that might be a second copy or just a deeper tier. They have a metadata manager and then some type of HSM, like a hierarchical storage manager, that essentially sits on top of this to efficiently manage this data. So whether it's images or videos, essentially your HSM and then a metadata manager like a digital asset management system is your interface into that, and then there's a layer of essentially storage management that goes on under the covers. So what we see is customers taking their journey to the cloud in steps and in phases. First, what we see is customers moving maybe to a cloud digital asset management, syncing metadata from on-premise and storing some of that data in Glacier. And what this allows you to do is get the efficiencies of Glacier and, say, eliminate that offsite tape archive, but essentially create another tier, and rather than it being essentially hours or days to access from your offsite tape, minutes from Amazon Glacier. And as I said, a pattern that we see and we recommend is if you're more actively accessing this data, you probably want to set up an Amazon Direct Connect connection. So the next step and the next phase that we see is then customers taking advantage of now that more active layer in Glacier and perhaps even eliminating that on-premise tape. And this allows you also to take advantage of elastic compute, elastic transcode, and other services inside AWS to transform and manage that data located in that archive. So again, this turns it from a more passive archive into a more active archive and takes advantage of, A, the cost efficiencies of Glacier, and secondly, the elastic compute and overall elastic capabilities of AWS. So then you can see the next, you have maybe then move to more of just a simple on-site cache. So now you're moving more data and you're moving some of the processing tasks out again from on-premise into the cloud. And over time, you're moving more and more of the data more of the active data into AWS. So that's the transition that we typically see, which is a hybrid environment for a little while, and then a transition to a fully cloud-based solution. And so let me now just codify that and share, rather than in an abstract way, a very specific customer use case. So Sony DADC has a group called Venue that is an internal group to Sony, where they have requests for video, so at different bit rates. So their workflow is something similar to the request for a new video that just came out, or an older video, and they want it in 10 different bit rates. In their old system, they would have an on-premise system. They would transcode that video master into lower bit rates and then distribute those to internal or external customers. And so what Sony's objective was really to significantly shorten that content delivery. And instead of having maybe hours or multiple hours or days, depending on where the data was located, they really wanted to have a target of under 1 hour turnaround and migrate completely away from that on-premise infrastructure. They have over 20 petabytes of assets and over 1 million hours of high-resolution content. So if you think about the use case, again, as I said, there's theatrical and television releases, there's a life cycle, and there's a long tail, if you will. So what Sony is a great example of is this active archive, where there's lots of fixed data that's unchanging, but at the beginning, perhaps it's much more accessed, and then over time it tears off and becomes cooler, and they still need to access that data, but a lot less frequently. And you can see Sony said if physical delivery is going to happen within 1 hour. This is a great quote. Surely we're able to exceed such expectations digitally. So again, that was the goal, the under 1 hour turnaround time. So the challenge was really taking the centralized repository and allowing availability to customers, and both internal and external, and actually bi-directionally, which is the additional challenge, to over 1,200 distribution points worldwide. There's over 20 petabytes of data and over 1 million hours of content, and a growth rate of a petabyte every quarter. And what their goal was over an under 1 hour delivery time and a really more agile, scalable, and predictable cost model. So here's a snapshot of what Sony was doing, their old infrastructure, where they had a 120 gig ProRes file. They would ingest that, they would take that, they would store it, and then they would store it on this combination of tape and disk for the hotter content. And then when a request would come in, the reverse would happen. They would take it from the tape or disk, they would encode it, and then they would deliver it. And the problem with this is that there was essentially, you had to anticipate, and as their storage grew, their requirements for both ingest and egress grew. And so what happened, the capacity and infrastructure that you have to build for that or accommodate for that grows, not just because of the capacity, but grows because of the amount of concurrency and requests. And since it's bi-directional, meaning you're both writing and reading data, you have to grow your network infrastructure, you have to grow your storage infrastructure, your compute infrastructure to be able to handle that demand in a bi-directional way. So what Sony was able to achieve with AWS and moving this entire workflow to AWS is essentially infinite concurrency, meaning infinite scalability in terms of ingesting data and ingesting new videos in, and so keeping up with that demand, not only from the storage capacity, but also from the network, compute, and other ancillary services that are required to get the data in. And then certainly any kind of peaks that come along in terms of then egress and distribution, where there's infinite concurrency as well and the ability to get it out. They're very excited about the expedited retrieval, 1 to 5 minutes, but also for different types of services, they're taking advantage of standard and bulk retrievals as well. I think this is putting it all together and stitching it all together for customers about why S3 and why Glacier for Active Archive. Here's a great comparison. Sony presented this at our reInvent conference in December. They talked about, and this is pretty typical for those customers on the phone that are looking at 5 or 7 year depreciations for tape and disk infrastructure. And you can see that over a 5-year period, there was a little bit over $2 million savings, and over a 7-year period, and over $5 million savings. And what you can see from this chart, without going into too much detail, is from a traditional CapEx model, you have a bump at the beginning and a cost there, and then over time, obviously, your costs decrease. And around year 4 or 5, actually, the CapEx model does turn a little positive as compared to the AWS model. But then when you're, again, so if you look a little bit further and you go through your next refresh then, and that's at the middle of after year 5 into year 6, all of a sudden you incur another capital expense. And so certainly at a certain point in time, you can see the small triangle there. There may be a slight benefit from year 4 to the middle of year 5 where the CapEx model is slightly ahead. But if you look over the period of 5 years or 7 years, whatever the horizon is, there's this gradual, if you will, very predictable cost model that you have for archive versus this really spiky CapEx model. And so that predictability and that basically pay as you grow is a real benefit to moving to the cloud. And certainly there are small points where CapEx might benefit, but I think overall you can see this is great graphical representation about for Active Archive, specifically about why cloud and why Glacier. So we talked a little bit about the different use cases. We talked about Sony. Let me wrap up with one last use case, and then we can open it up for questions. But for those regulated industries like insurance, financial services, and healthcare, there's a compliance requirement. And with that compliance requirement comes a retention period. So Glacier has a capability called Vault Lock, which allows you to easily set compliance controls on individual vaults and enforce them via a lockable policy. So there are a number of capabilities, including time-based retention. You can control all the records in a vault, and then there's an immutable policy, 2-step locking, meaning first you set the retention period, and then you say, I want to enforce that retention, and that data becomes not only immutable, but not deletable, undeletable for that period of time. So Glacier Vault Lock is a non-overwrite, non-erasable record solution, time-based retention, policies, and then also the ability to have legal hold with vault level tags. So say, for example, you have a discovery going on, you can lock down certain vaults for that legal period independent of the retention period. So there's a legal hold capability as well. And then we actually worked with a third party called Cohasset Associates, and they validated and went through, and there's a white paper on the AWS site about this, that went through and validated against SE 17A4 and CFTC 1.31B and C requirements for the financial services industry, that Glacier Vault Lock met those requirements. So it's a detailed white paper that goes through each one of those requirements and shows that Glacier Vault Lock met or exceeded those requirements. So we wrap up with a customer who is taking advantage of this retention capability and compliance capability within Glacier, a company called Proofpoint. They're a cloud-based security and compliance company for the enterprise. Threat research, email, mobile, social, and digital risk. They've been around a bit over 10 years, and as you can see, 300 million annual revenue, 3 billion market cap. So they have a solution called Social Patrol, and essentially what this allows you to do, this solution is, which is built in AWS, is policy controls and enforcement for social data. So whether it's Facebook's or Twitter's, LinkedIn, essentially what this ensures is it's a constant scanning of data and then retaining of that data, whether it's textual, image, or metadata. And so what they're doing is ingesting over 1 million social posts per day. And so what companies can do is take advantage of this. Under the covers, they take advantage of Glacier and Vault Lock to take the data, all these posts, images, and links, and lock those down for a period of time and make sure and prove that it's immutable. So I'll go into detail here as I build this out. So essentially, you can specify within their Proofpoint product a 3-year retention period, and you want to archive all of the Twitter feeds and all the Facebook posts about a particular company. You want to archive that historical content. So you can see that this retention period is going to be around for 3 years, and that means that that data cannot be deleted, and the deletion or worm compliance is enforced for that period of time. So you can see here, then, if you dig down at the next level for this customer and how that looks under the covers, if you will, what Proofpoint does via the Glacier API at the Vault Lock level. They've locked it down, and you can see that each, the number of archives they have for each one of those customers and the policies associated with those customers. So finally, you can then take a look and you can see on the screen that the Vault Lock policy is locked and that data now cannot be deleted for a specified period of time. Again, from a customer perspective, this is all under the covers. The high-level takeaway is that we can enforce the retention period of 3 years at the Glacier tier via programmatic API. So as you're building solutions, you can enforce that very easily via the API and via a very simple interface directly into Glacier, as Proofpoint has done. So with that, I want to just put up a screen of our Active Archive resources, S3. We have some great sessions that we have from reInvent that dive a little bit deeper into S3 and on Glacier. We have the Cohasset assessment, the Sony case study that I talked about, and then a TCO calculator for your own use that's available on AWS. So with that, I thank you, and we can open it up for questions in the remaining time.
Great, thank you so much. We're going to turn it over to live Q&A now. Give me just a moment here to pull up a couple of questions. Wonderful. So thank you so much, Mark, for a great presentation. We have time here for about one question, and we'll just look for one of these questions here. Mark, it looks like we have a question from Larry. Can I restore directly from Glacier to an EBS volume, or do I have to put it into standard S3 first prior to moving it to EBS?
Right. So we can when you store an EBS snapshots. I assume that is the question about EBS snapshots. So EBS snapshots are stored in S3. So you would restore it from S3 into EBS. Again, depending on the question, but you would stage it first in S3 and then move it out and then rehydrate it directly into